In this proof we're going to look at the total resistance for three resistors connected in series. In the picture that we've got, we have a battery that has a voltage of V amount of volts, and then we have three resistors, R1, R2 and R3, connected up after each other. There's one electric current flowing in this circuit because we have one loop and therefore one current flowing through each of those three resistors. So what we find is that the voltage coming from our battery is going to have to equal to the voltage drop across each of our three resistors. The voltage drop across each of the resistors we're just going to call V1, V2 and V3. So when we apply this idea of a voltage drop across each of the resistors, each of those three resistors will obey Ohm's law. So for each of them, they will still obey the formula V is equal to IR, where V is volts, I is the electric current, and R is the resistance. If we apply this to each of the three resistors, for the first resistor, its voltage drop is going to be called V1, and it's going to be the current multiplied by its resistance. The same equation applies to the second resistor, so we get I by R2, and then for the third resistor, its voltage drop, which is V3, is I by R3. We know that if we add those three voltages together, the voltage drops across the resistor, they have to add up to the voltage coming from our battery. So the V from the battery is equal to V1 plus V2 plus V3. What we then do is, instead of having V1, 2 and 3, we're going to substitute in the current by resistance for each of the three resistors. In our battery, we can remember that if we just use Ohm's law, V is going to be I multiplied by the total resistance. Across each of our three resistors, we have the current by the resistance for each of those. And what we're going to do next is we're going to factorize out the current from each of the right hand side parts. So we have the current over on the left hand side being equal or being multiplied by the total resistance. When we factorize out the current from the right hand side, we get the current, which is still the same one current that's flowing in the circuit, but then this time it's going to be multiplied by R1 plus R2 plus R3. We can see that we have a common factor on both sides, which is the I, so it cancels. We then have that the total resistance in the circuit is R1 plus R2 plus R3, which just are our three resistance values for each of our three resistors. And that's the derivation of the resistors in series formula.